I am General Scanning. I am happy to have this opportunity to speak to you young men who soon will become flying officers in the United States Air Force. Yours can be a rewarding future in your chosen career of military aviation. Have no fear that you have arrived too late to be an active participant in aviation's progress. Everything worthwhile hasn't been invented yet. At the turn of the century, a noted scientist remarked that all of the important discoveries had been made and that the work of the future scientist would be only to refine the work of the past. Since then has come the discovery of X-rays, radioactivity, the structure of the atom, radio waves, and the theory of relativity. Indeed, some scientists say that man has learned as much about physics in the past 65 years as he did in all previous recorded time. And so it is with aviation. We are just beginning to learn about this relatively new thing called flying, and I believe the 50 or 60 years just past will not be the most challenging period in aviation. I am not making idle predictions just to please your vanity or to convince you to make the Air Force your career. A seemingly unimportant event sometime early in World War I has had a profound effect upon man's history. It was the first shot fired by an aircraft pilot at another man flying a similar machine. That shot placed man in a new dimension of combat, free from land and from the sea. It gave him an added mobility, which combined speed and range and extended his military effectiveness to new horizons. A generation later, World War II proved the absolute necessity of controlling the air if final victory is to be achieved. Since that war a generation ago, I have been privileged to see our Air Force established as a separate arm of the service, have seen it grow into a vital arm of our nation's defense, while at the same time we have leaped from subsonic speeds to space. This film will acquaint you with some of our present-day aircraft in the operational inventory, and with a few of the newer aircraft, some still in the test phase, which you will be seeing and flying in the future. This is the F-4C. It can carry 11 M116 or BLU-1 napalm bombs. In addition to its 4 semi-submerged Sparrows, this aircraft carries a full complement of conventional weapons and also has a nuclear carrying capability. Its maximum bomb load is more than twice that of the World War II B-17. The F-4C, powered by 2 GE J-79 engines with afterburners, has a range of more than 2,000 miles without in-flight refueling and has been flown to an altitude over 90,000 feet. Its complement of 2.75 rockets is carried in the LAU-3 launcher on 15 positions. These can be released singly, in pairs, or in salvo. The F-4C carries 20mm cannons with a firing rate of 6,000 rounds per minute. The gun pods may be carried on the center line or on both outboard stations. The F-4C carries a full complement of Sparrows and can also carry 11 750-pound bombs. Here we see a complete salvo of 750s being released and hitting on the target. The next vehicle is a tilting wing type aircraft which was brought out in 1964. It's the XC-142A and is our largest V-STOL aircraft. It is also the first tri-service aircraft to be flight tested by the Air Force, the Army, and the Navy. With its wings rotated, the XC-142A can lift off vertically at 37,500 pounds gross weight, or it can take off as a conventional short field transport at 41,500 pounds with payloads up to 8,000 pounds. Flight testing of the XC-142A began in September 1964. In this scene, you'll note the aircraft has transitioned to forward flight, and now we observe it as its wing is tilting, preparatory to hovering for a vertical landing. You will note the configuration at this time is quite similar to our ordinary helicopters, and the touchdown is much the same as conventional rotary wing type aircraft. While the XC-142A was flying to glory in front of the hangar, our Air Force engineers were still working out in the back lot. They were working on the next generation of vertical takeoff aircraft. We had quite a bit of trouble finding a qualified test pilot on this particular vehicle. All of our regular test pilots disappeared quite early that morning to sick call or other administrative duties. Believe it or not, I had to fly this hot job myself. You will note that it is quite unconventional in its takeoff mode. The F-105 is actually a one-man flying arsenal. It carries a Sidewinder air-to-air missile among many other stores. In this scene, note the hit of the rocket previously fired. The 20mm nose cannon, when used on a strafing run, is extremely effective. This shows what can be done to a simulated target. Among its many capabilities, the F-105 Thundercheif can carry as many as 9 napalm bombs as part of its stores. Another example of its versatility is the capability of the F-105 to launch a variety of rockets against ground targets, including the deadly bullpup. Note the direct hit by this weapon, and all this in any weather and at a speed just under Mach 1. Here's an F-105 with a full complement of 500-pound bombs ready to demonstrate its airborne firepower. When airborne and over the target, the pilot can deliver a bomber-sized payload singly, in pairs, or in a salvo. This, plus all the many other distinct features of the F-105 aircraft, truly make it a one-man arsenal. Here's an example of modern-day facelifting and the modification of existing retired aircraft into new modern roles. This is a World War II Type A-26 converted into a B-26 and then into a B-26K model. For a long while, this aircraft was just sitting on the scrap heap at Davis Mountain Air Force Base. As you can see, it's practically a brand new aircraft. It's been redesigned to support special warfare requirements, including attack, reconnaissance, observation, and surveillance. It can operate anywhere from 30,000 feet down to the deck, carries 850 caliber machine guns, and a very substantial load of stores. These stores can be varied to include napalm, rocket launchers, grenade dispensers, and flares. This is the YF-12A, powered by 2 Pratt & Whitney engines. It was built in secret between 1959 and February 1964, when it was first unveiled by the President, and it has a combat radius of more than 1,000 miles. This scene shows the YF-12A taxiing out for takeoff at Edwards Air Force Base and gives an excellent view of the planform of the aircraft. It can fly at Mach 3 at extreme altitudes and streak from bases deep within the United States. It can engage enemy bombers many miles before they reach their launch point for air-to-surface missile attacks against our country. Unlike present-day interceptors, it can launch its missiles against high or low targets without changing altitude or heading. The missiles can be equipped with conventional or nuclear warheads. By the combination of its own speed and the speed of the missile, it intercepts targets at a rate of more than 4,000 miles per hour. In this landing scene, you will note the high angle of attack attitude while it touches down and deploys the drag chute. The XB-70A flew for the first time in September 1964. I have a personal interest in this aircraft because I directed the program for more than 3 years and was happy to be in charge of the program when it was rolled out. Believe me, I sweated out that first flight, even though I was no longer in charge of the program at the time. This is the liftoff on the first flight. The XB-70A is the largest, heaviest supersonic research aircraft ever built. It grosses over 1/2 million pounds, is 185 feet long, and has a wingspan of 105 feet. Many new and important features have been incorporated into its construction, such as all-welded honeycomb stainless steel airframe and its use of compression lift to increase aerodynamic efficiency. This is the touchdown on the first flight. Note that the left landing gear starts streaking flame. 2 of the wheels locked, which of course blew the tires during the roll. But there was minimum damage. The pilots reported no loss of directional control. As the XB-70A came to a halt, emergency firefighting equipment extinguished the fire. You will notice the rear wheels worn down because of sliding on the runway. The XB-70A features variable geometry inlets, hinged wingtips for greater stability at supersonic speeds, and integral fuel tanks which are used as heat sinks. On flight number 4, the wingtips were lowered 65 degrees, which resulted in an immediate and significant increase in the directional stability of the aircraft. During a very recent test flight, the XB-70A reached a speed of Mach 3 and an altitude in excess of 70,000 feet. These are the design conditions called for in the original specifications. Concepts incorporated in the XB-70 have opened the door to a whole new generation of Mach 3 cruise-type aircraft. Our largest operational jet cargo aircraft, the C-141, is capable of carrying a 62,000-pound payload, 4,000 nautical miles, at more than 420 knots. At 5,000 feet and 150 knots, 7 separate loads of 10,000 pounds each were dropped in just 30 seconds. One aircraft was test flown 2,500 hours in only 11 months. This was an average of 7 hours a day, every day, during its flight testing at Edwards Air Force Base. These are the new F-5A Freedom Fighters. They were developed from the T-38 and are being produced for the Military Assistance Program. This aircraft was designed to be quite versatile. It has the capability to take off and land on rough terrain or sod fields. The twin jets boost the F-5 to 50,000 feet and to a speed of 1,000 miles per hour. The F-5A can carry more than 6,000 pounds of stores from 2.75 rockets to 750-pound bombs. Also the GAM-83 Bullpup missile and the heat-seeking Sidewinder missile. Let's watch this flight drop its cargo of stores and see what happens. Here we see both bombs and napalm being dropped and their hits. The F-5A is highly maneuverable, as can be seen here by this dive bomb drop at low level, the pull-out, and the rolling climb. This gives some idea of what the new F-5 will carry in the way of stores. Here is another demonstration of rocket firepower by the F-5A. And now the Bullpup. Pilots for the F-5A aircraft are trained in this country before the aircraft are turned over to the Military Assistance Program countries for their use. Data derived from Project Mercury and other activities have shown the need for training pilots for spaceflight. Therefore, 3 F-104A aircraft were modified into aerospace trainers and redesignated NF-104A to help fill this need. This aircraft bridges the gap between high performance and orbital aircraft. Greatly improved performance is attained by this LR-121 liquid fuel rocket engine. There is a reaction control system consisting of 2 nozzles on each wingtip for roll control. 8 other nozzles in the nose area are for control of pitch and yaw when the aircraft is flying at low dynamic pressure at extremely high altitudes. This is the single control used for the reaction jet nozzles. Ground handling characteristics do not differ much from the F-104. It can leave and return to its parking area under its own power. Flight characteristics of the aerospace trainer are very similar to other F-104s except when under rocket-powered flight. On a typical flight, the rocket engine is ignited at about 35,000 feet until 100% of power is reached. From then on, the pilot climbs to 40,000 feet, accelerates to Mach 2.2, and does a 3G pull-up. The jet engine flames out at 80,000 feet, and the reaction control is then used. The pilot has the option of landing without power, like the X-15, or restarting at 40 to 45,000 feet and landing under his own power. The YA-T-37 is an experimental counterinsurgency aircraft which is a modification of the T-37 primary trainer. More powerful engines give it a much shorter takeoff than the T-37. Beefed-up wing structures enabled it to carry 3,000 pounds of stores and wing tanks for greater range. It also carries nose guns and armor plate for crew protection during low-level operations. The Tweety Bird is familiar to you, of course, but did you know about all the engineering headaches that went into its development? Here are some scenes from the rollout. And then from the first flight. And now we have the full power dive test with re-entry from outer space and a typical water recovery. The most exciting aircraft produced and flown recently is the new swept-wing F-111. It is our first true multi-service, multi-purpose fighter bomber. This radically new aircraft was designed to meet a variety of stringent operational requirements for both the Air Force and the Navy. Among the many unique features of the vehicle are side-by-side seating and a two-man escape capsule. The F-111 uses approximately 3,200 feet of runway for takeoff with wings fully extended. The aircraft is at the end of the runway for engine run-up and last-minute check. Now the pilot applies full power and afterburner. The takeoff roll is extremely short with wings fully extended. The most unique feature of the F-111 is the variable sweep wings. With wings fully extended, it has long ferry range and can loiter at high altitudes for extremely long periods. In this scene, you can see the wings being swept back to the closed position. The pilot moves the wings much the same as he would open or close the throttle, pulling the control mechanism to the rear to move them forward and slow down the aircraft, and the opposite when desiring to accelerate. This simulated reading of a Mach indicator shows the rapid acceleration. The pilot slides the wing bar forward and the wings fold back. He applies full thrust with afterburner and his aircraft really starts making knots. Again, note the simulated acceleration. With its terrain-following radar, the F-111 operates as a low-level supersonic bomber capable of avoiding enemy defenses. Or it can follow the same procedure at higher altitude over mountainous terrain at supersonic speeds. The variable geometry F-111 gives the Air Force and the Navy an aircraft with great commonality, unprecedented flexibility, and the capability of performing a variety of functions for both military services. There you have a quick glance at the Air Force today. Of course, we are flying many other types too, but I believe these are representative of the aircraft you will soon be flying. Another very interesting vehicle we will be seeing soon is the Manned Orbiting Laboratory, or the MAL. The MAL, of course, is way out, into space. And I hope it is just the beginning of Air Force responsibilities in that medium. What will the coming years bring? No one knows, of course, but yours will be the opportunity to share in that future. I am not making idle predictions just to please your vanity or to convince you to make the Air Force your career. A seemingly unimportant event sometime early in World War I has had a profound effect upon man's history. It was the first shot fired by an aircraft pilot at another man flying a similar machine. That shot placed man in a new dimension of combat, free from future in your chosen career of military aviation. Have no fear that you have arrived too late to be an active participant in aviation's progress. Everything worthwhile hasn't been invented yet. At the turn of the century, a noted scientist remarked that all of the important discoveries had been made, and that the work of the future scientist would be only to refine the work of the past. Since then has come the discovery of X-rays, radio from land and from the sea. It gave him an added mobility, which combined speed and range and extended his military effectiveness to new horizons. A generation later, World War II proved the absolute necessity of controlling the air if final victory is to be achieved. Since that war a generation ago, I have been privileged to see our Air Force established as a separate arm activity, the structure of the atom, radio waves, and the theory of relativity. Indeed, some scientists say that man has learned as much about physics in the past 65 years as he did in all previous recorded time. And so it is with aviation. We are just beginning to learn about this relatively new thing called flying, and I believe the 50 or 60 years just past will not be the most challenging period in aviation. I am General Ascani. I am happy to have this opportunity to speak to you young men who soon will become flying officers in the United States Air Force. Yours can be a rewarding